All right, multiple choice. Which of the following is properly labeled? HNO2 is a Lewis acid. HNO2 is a Lewis base. HNO2 accepts a proton. H3PO4 is a strong base, and HCl is a strong base. Starting at the bottom, HCl, that is not a strong base. HCl is one of our strong acids. So it's important to remember those strong acids. Hydrochloric acid is a strong acid. Sodium hydroxide is a strong base. Let's see, sulfuric acid, hypochloric or HClO4, hypochlorous acid is strong acid. Remember your strong acids, remember your strong bases. Okay, but I'm going to remove that as an option. H3PO4, that's phosphoric acid. By virtue of it being phosphoric acid, it's not a strong base. HNO2 can accept a proton. That's kind of a tough one. Well, what would that look like? That would look like this: HNO or H2NO2, and it would be positively charged. Now, if you wanted to look at that in terms of molecularly, what would it look like? Or like the Lewis structure. Well, what that would look like is this. Sorry, it's not on that. Yeah, it would probably look like that. An OH. And so that would put that nitrogen with a positive charge, and that nitrogen's really not going to want to take that positive charge on. So HNO2 is not going to accept a proton. Next up is HNO2 is a Lewis base versus HNO2 is a Lewis acid. Well, HNO2, what it looks like as a molecule is this right here. And what it can gladly do is separate into H plus and O and O2, and have that negative charge, and it's good to go. It's going to dissociate into that. So HNO2 is not a very good base. NO2 isn't a bad one, but HNO2 is more of an acid than anything else. And specifically, it's going to be a Lewis acid because it can donate that proton, which is what we're looking for when we think about a definition of a Lewis acid. I hope that was helpful, just to kind of keep you aware that you need to think about your Lewis acids and your strong acids and your strong bases. Hope that was helpful. See you in the next question.